issues on a day-to-day basis. It's incredibly important we accelerate the advent of sustainable energy. Time really matters. This presentation is about accelerating the time to sustainable energy. But a lot of people may not be aware that wind and solar comprise 75% of new electricity capacity in the US this year. So this is a really major. In the past 10 years, power production from coal has dropped in half. So it went from 46% of electricity in 2010 to 23% in 2020. So this is a massive improvement. So good things are happening on a lot of levels. We just need to go faster. So in terms of Tesla's contribution, we've delivered over 1 million electric vehicles, 26 billion electric miles driven, and many gigawatt hours of stationary batteries, 17 terawatt hours of solar generated. So to accelerate the transition to sustainable energy, we must produce more EVs that need to be affordable and a lot more energy storage while building factories faster and with far less investment. So goal number one is a terawatt hour scale battery production. So Tera is the new Giga, and a terawatt is 1,000 times more than a gigawatt. So we used to talk in terms of gigawatts. In the future, we'll be talking in terms of terawatt hours. So this is what's needed in order to transition the world to sustainability.
Yeah, and you can see we're talking about 100x growth in batteries for electric vehicles to achieve this mission. And we are going to get there. It's just a matter of how fast, and our intention is to accelerate it.
Yeah, you basically need on the order of roughly 10 terawatt hours a year of battery production to transition the global fleet of vehicles to electric.
And the average vehicle lasts 15 years, so we're talking about 150 terawatt hours, give or take, to transition the whole all vehicles of all types to electric. And then on the grid side, we have a similar mountain to climb, 1,600 times growth from today's grid batteries to go 100% renewable on the grid, and to take all of the existing heating fossil fuel uses in homes and businesses 100% electric.
So today's batteries cannot scale fast enough. They're just too small. For Giga Nevada, 150 gigawatt hours per year is like what we probably expect to make out of there. But this is really pretty small in the grand scheme of things. That's only 0.15 terawatt hours. And it costs too much. So
we would need 135 fully built out Nevada gigafactories to achieve 20 terawatt hours a year. It's not scalable enough of a solution. We need a dramatic rethink of the cell manufacturing system to scale as fast as we can and should.
Goal two, obviously, we need to make more affordable cars. I think one of the things that troubles me the most is that we don't yet have a truly affordable car, and that is something that we will make in the future. But in order to do that, we've got to get the cost of batteries down. We've got to and we've got to be better at manufacturing, and we need to do something about this curve. The curve of the cost per kilowatt hour of batteries is not improving fast enough. It's starting to flatten out a little bit because the rate of improvement of the affordability of cars is just not fast enough.
We have a plan to halve the cost per kilowatt hour.
Yeah.
We've moved from the 18650 form factor to the 2170 form factor through great collaboration with our partners, Panasonic, new partners like LG and CATL, and probably others in the future.
Yeah. Actually, so a slight note on why is the one called the 18650, although not on the slide, versus the 2170, is that the first two digits refer to the diameter, and the second two digits refer to the length.
And so when we put it all together and go to our new 80 millimeter length, 4680, we call this new cell design, we get 5 times the energy with 6 times the power and enable 16% range increase just form factor alone. So just the cell form factor change enables a 14% dollar per kilowatt hour reduction, just that cell form factor change. And through all of that development, we were able to get to the point where we can implement assembly lines, one line, 20 gigawatt hours, 7 times increase in output per line. And when you're thinking about scalability and pure effort, having one line be 7x the capability is just effort multiplying.
Yeah.
And when we take that anode cost reduction, we're looking at another 5% dollar per kilowatt hour reduction at the battery pack level. And there's more. At that point, we have an awesome resource in those batteries to recycle to make new batteries. So we don't need to do any more mining at that point, and you can see why.
Yeah.
We talked about scaling cathode and recycling. All of the benefits that you just saw are added to this benefit of a 12% reduction in dollars per kilowatt hour at the battery pack level.
Making the currently making the entire rear section of the car as a single piece, high pressure die cast aluminum. And in order to do this, we actually had to develop our own alloy because we wanted a high strength casting alloy that did not require coatings or heat treatment. So instead of having these like supports and stabilizers and stringers and structural elements in the battery, we now have a lot more space in the battery because the pack itself is structural. So 10% mass reduction in the body of the car, 14% range increase, 370 fewer parts.
In addition to the improvements we just said on enabling additional range and improving the structural performance of the vehicle, it is worth another 7% dollar per kilowatt hour reduction at the battery pack level, bringing our total reductions now to 56% dollars per kilowatt hour.
Yeah.
So range increase, we're unlocking up to 54% increase in range for our vehicles and energy density for our energy products. 56% reduction in dollars per kilowatt hour at the battery pack level, and a 69% reduction in investment per gigawatt hour, which is the true enabler when we talk back about how do we achieve this scale problem here.
Yeah. Yeah, so what this enables us to do is achieve a new trajectory in the reduction of cell cost. And now, to be clear, it will take us probably a year to 18 months to start realizing these advantages, and probably to fully realize the advantages, probably it's about 3 years or thereabouts. What does it mean for what does this mean for our future products? We're confident that long term we can design and manufacture a compelling $25,000 electric vehicle. This has always been our dream from the beginning of the company. I even wrote a blog piece about it because our first car was an expensive sports car, and then it was like slightly less expensive sedan, and then finally sort of a mass market premium, but like the Model 3 and Model Y. But it was always our goal to try to make an affordable electric car, and I think probably, like I said, about 3 years from now, we're confident we can make a very compelling $25,000 electric vehicle that's also fully autonomous.